Students, last session we were discussing about the various object-oriented database features like object identity, then object structure and type constructors, and we have seen the various structural details about how to define a new type in a basic way, and also we have seen some example where we are able to explain a complete object that was corresponding to a company database. So we have seen some sample company relation and its subtables and some of the objects that can be created, or the type of those objects can be created by using some basic syntax of object-oriented databases. And also we have seen a detailed structural example how these objects are connected from one object to another object. And today's session will be focusing on some more features of the object-oriented databases. So we'll be discussing about encapsulation of operations, methods and persistence of the objects present in an object-oriented databases. So as you know, you'll be familiar with the term encapsulation, which is the common property of any object-oriented programming language. Similarly, when we are using object-oriented databases, here also we consider the feature called as encapsulation, where we are having the collection of all the properties and the operations that are tied into a single unit, which is commonly called as a class in object-oriented languages. So the similar concept is followed in object-oriented database also. So this is one of the main characteristics of any object-oriented programming language. Similarly, in object-oriented database system also. So this encapsulation is related to the concept of abstract data types and information hiding. So we are aware about these two terms, abstract data types and information hiding. So abstract data type means in order to provide the creation of an object, we are maintaining some information in a class format, and after the creation of those classes, we will be using the classes for creating further objects, or sometimes the same classes for creating some other classes. So every classes will be having different structure. So these formation of classes by collecting a number of variables and operations together are actually called as abstract data types. Similarly, information hiding means some certain informations are to be hidden from the outside world. So we can have the provision of keeping some elements or some operations in a private mode inside the class. So here also we can provide some information can be hidden from the external world so that it is not directly visible to the external user. So that property is called as information hiding. So these two concepts can be implemented by the usage of the basic object-oriented concept called as encapsulation, which is usually like the creation of a class. So a class normally provides the encapsulation properties by adding all the necessary data in the terms of variables and operations, and providing some of the data in a hidden format so that others cannot have an access to that internal data. Now during this encapsulation, we will be having different operations or methods available. So these class operations are normally specified by using the object behavior. That means which is usually called as an object behavior. So how an object will be behaving, which is actually defined in terms of various operations. So in object-oriented programming language like Java and all, if we are going to perform some operation, we are using a function or a method that consists of some logic. So that means an object name dot that function will decide how that object will be behaving. Similarly, in object-oriented database also, if we add some operations into the class, this will decide how the particular object that is created based on that class will be behaving. So the main idea is to define the behavior of a type of object based on the operations that can be applied externally by the objects. So object.operation will decide the name of the operation that we need to specify separately. You should know the name of the operation, and object name dot operation name will decide the object behavior based on the definitions given in the operations. In general, the implementation of an operation is like the body of a function. So operation can be a function here, and implementation can be the body of the function or operation. It can be specified by using, in an object-oriented programming, object-oriented database system, the implementation is not done by using any database related operations. That must be written as a separate block by using any of the object-oriented programming language. So that will be written somewhere. So whenever we use the object for performing that particular operation, operation is written by using some other object-oriented programming language, either by C++ or Java, that is written and stored separately. But from the database access operation, the object name dot that operation name will be invoked, so that the operation body will be executed on the data associated with that particular operation. Now, for database applications, the requirement that all objects be completely encapsulated is it means one of the problem with object-oriented database is if we do complete encapsulation. If you do complete encapsulation means that must be very strictly or very stringent into that class, and without having any access to any external word. So it is not always possible to do the complete encapsulation. So how we can relax on that? It will be by dividing the entire structure into two different parts. One is the visible portion and second one is a hidden portion. So visible or hidden attributes, which is commonly called as instance variables. So in C++ or Java, the variables declared inside a class is usually called as instance variables. So instance variables are the variables associated with objects. So different objects, these variables will be having its own value. That means they are different instances. So some of the variables are visible to the external world, and some of the variables are hidden. Not only variables, in the meantime the operations can also be visible or hidden from the external world. Now we can see one of the example in which we are including operations also. So in the previous video when we were discussing the creation of an employee, it was simply like we were focusing on type constructor alone, where it consists of some of the data elements that follows some of the type constructors like set, array, then tuple, etc. Now this example is a specific syntax by using the class concept, where we are creating a class type structure, and inside the class structure we are going to define a number of instance variables, and along with the instance variable we are also adding a number of operations also. So encapsulation is possible only by adding the instance variables along with the operations. So these two together only can form the concept called as encapsulations, because these operations are also always required for the behavior of a particular object. So these behaviors or operations can also be, sometimes it is visible, or it can also be a hidden thing, but that can be decided by the designer of this object-oriented databases. So we will be having some modification on the previous syntax where we were discussing about type constructors. So earlier we were discussing about define type employee. So here we are changing that into a specific object-oriented database syntax. That is, we are going to define a class employee. So the syntax will be like define class employee. It is almost similar to the creation of a class. Only thing is we are adding one more keyword called as define. So in C we will use class employee, but here we are using define class employee. So normally class names are provided by using capital letters in these syntaxes in order to separate from other variables or operations present in our example. Then employee is the class name. Then inside the employee we are having a type constructor tuple that is being added first. So type tuple, then within the bracket I will be defining one instance variable f name, colon, its type is string, then m init, its type is char, l name, its type is string, ssn, it is string again, birth date, it is given another class type, that is a date type. So that is to be defined separately. Then we are having address, again string, sets again char, salary is a float type. Then I am giving a supervisor attribute which is having another user defined type which is called as employee. That is that is not another one. A supervisor will be having all the properties of an employee, so it will be like following the structure of the same class. A supervisor is following the structure of the same class. Then we are having a department attribute which follows another class which is called as a department. Then finally put a bracket and put a semicolon that defines this type that is called as tuple. Okay, so this portion is over because the type is tuple. That is why we are putting these into between this open and close bracket, and we are separating all these attribute name, colon, type. Then by using semicolon we are separating all these. Then after the completion of this tuple we are putting a closing bracket and put a semicolon. It can be considered as a single set of values because the first element of employee is of type tuple, consists of this much number of values. Now the second portion we are going to add some operations into the same class employee. So we need to use operations. So here type tuple or type some other type, whatever type we are using that can be specified, and the description of those type can be given here. Then we are going to write operations. What are the operations we are going to define here? It is just like explaining different functions in C++. So the first operation is age colon integer. It is just like integer age of function, just like a age function. Age function will be like this one, integer age function, integer age function. So it will be like integer age function. So here we are following this format, age colon integer. As it is coming under operations part, this age is a function which returns an integer value. Similarly, create underscore emp is another function or operation which returns an employee type. For creating an employee, we'll be having a function or operation called as create underscore emp, which will return an employee type value, means which will be again following all these structure. Means create employee is returning an object of type employee. Age is returning an integer value only, but create emp is returning an object of type employee. Then we are having another method or operation which is called as destroy underscore emp, which will return a boolean yes or no value. That is, destroy employee is used to remove the employee or destroy the employee from the database. After the destroyal, it will return a boolean value yes or no. So the body of age is written separately, and that is stored separately by using C++ or Java. Similarly, the body of create employee is also written separately, and destroy emp is also written separately, and that is stored separately inside the system. And whenever we access this database using this object-oriented database class employee and its corresponding object, and whenever we try to invoke this function, while invocation it will refer to the place where this operation body is implemented. That will be referred. It is not written, or the definition of this is not written as part of the class definition. Okay, so now this is the, so after specifying this tuple type and these operations, we are going to stop the class employee, so it must be ended with end space employee semicolon. So this is the way in which we are defining a class employee. So look at the differences. Define class employee, then tuple type, its tuple information, then a set of operations, then end employee. So it consists of mainly 4 parts: the class header, then a tuple portion, then operation portion, and the conclusion, that is the end of the employee. It will define a class called as employee. Now you can see that there are some user defined classes that are given here. That is, one is gate, one is employee, which is the same thing, and another one is department. So we look into the creation of department class. So similarly, we will try to create department class given by define class department, the same format, type tuple, which is having dname string, dnumber integer, then we are having a manager, which is again a tuple. So manager attribute of department class is again a tuple, which consists of a manager with employee type, which is again a user defined class type, start date, which is again a user defined class type, then put a bracket and semicolon. This portion is over, manager portion is over. Then again it is having another attribute locations, which is set of string, set of built-in type, then employees, each department will be having employees, set of employee, so it will be referring to the object of class employee. Projects, set of project, so we will be having another class project that is to be defined separately. So into that a number of projects will be added into the class department. So the first portion of department class is a tuple with these values. Among this manager is also further a tuple with more than one attributes. Then others like locations, employees, and projects are a set of some are built-in type and some are user defined type. Then we are going to define a number of operations here in this department class. Number of employees, which returns integer, that is to return the number of employees present in a department. Then create department. So create department will create a department and it will return an object of type department. Then destroy department will destroy the department and it will return either true or false. Then assign employee within brackets. So this is an operation that consists of a parameter. All other operations, even in the case of employee also, we are not having any parameters available, but here you can see assign employee, we are having a parameter that is e:employee. That means an employee object is the parameter there, which returns boolean type. Assign an employee, so a parameter employee object is given here. That means adds an employee to the department. That means one employee object will be given here, and assign employee, the body of that will assign that employee into the corresponding department object. Similarly, remove underscore employee, again I am providing an employee object here which returns a boolean type. It will remove an employee from the existing department object. So this is the way in which we are specifying a number of operations. So some of the operations may be without having any parameter, and some of the operations are having some parameters also. Now these two operations are having only one parameters. We can have more than one parameters, that is also permitted. Then after this we will be concluding the department by using end space department semicolon. So this is the syntax of the creation of a class. Why we are calling it as class means a class will be providing the property or feature called as encapsulation. So this entire example provides the explanation of the encapsulation, where we are wrapping up of all the data and operations into a single unit called as class. So we are having a class employee, department. These two classes are defined here. Among that, we are using some other classes also, like date, project, etc. That is not given here. That is also to be defined separately by using the same define class, date, define class, project, etc. I hope it is clear. So this is a little more specific syntax based on object-oriented database system. Now, in continuation with the same encapsulation of operations and method, we will see a mechanism called as object persistence. How we can persistently or permanently store an object into the system. How we can have the storage of those objects. How we can refer to a particular object, whether that object is persistent or not. So it can be done by using two mechanisms. One is called as a naming mechanism, how we can assign or refer to a particular object, and second one is by using a reachability mechanism. So the specification of object persistence can be done by using either naming or reachability mechanism. So what is this naming mechanism? In the case of naming mechanism, we will provide a unique persistent name for every object. So every object will be assigned a unique persistent name through which it can be retrieved by this and other programs. So it's, for example, this is the name of an object, and we are assuming that this is the persistent name. We are giving a permanent name to a particular object, and by using this X, every time we can access to this object by using the name X. So we are providing a persistent name. A permanent name is given for a particular object. We are assigning a name for that, and directly by using that object name we can refer to this particular object by using the name of any object. But the second mechanism is called as reachability mechanism, where an object is reachable from some persistent object. That means it is not always possible to keep all the objects as persistent object. Some of the objects to be kept as persistent object or permanent object, and the object can be reachable through the support of some persistent object. That means an object B is said to be reachable from an object A if a sequence of references in the object graph lead from object A to object B. So A is there, B is here. Now if it is A is a persistent object, for example, and if B is reachable through A, in any outside world, B is not persistent object actually, but it is possible to have access to B through another persistent object called as A. Then B can be accessible, or we can also say that B is also persistent because through another persistent object we can have access to the B also. So we will see one more case where we are using this reachability mechanism. Now in traditional databases like relational data model, we are giving an assumption that all the objects that are present in relational model is considered as persistent. All the objects are considered as persistent in the case of relational data model or entity or enhanced entity relational EER model. So all the objects, because we know relational model, some of the relational model supports object orientation also. So there we are considering all the objects that are created as persistent. But in the case of object-oriented approach, a class declaration specifies only the type and operations for a class of objects. So in the recent concept, the recent definition that we were creating in our previous example where define class employee was created, there we are specifying only the type, the different type and the operations present for a class of objects. So what we are doing is the user must separately define a persistent object of the type set. For example, we are having a class called as department. We need to create a new persistent object which is of type department set of department set, or list of department list, means a group of departments, a group of or set of departments. That means for keeping a number of objects, for example a number of balls are there, we'll be using a basket to store all these balls. This basket can be called as a persistent object. That means a set of balls. And what are the contents of that? A number of balls are there. So these balls, so what we are doing is this basket will create a basket which is of type set of balls, and we will be assigning this as persistent. And from we can take this ball from this basket, right? So these individual balls are accessible through the persistent object called as set of balls, that is the basket. So this is the way how we are maintaining. So every object cannot be given a persistent name, that is a difficult task. So what we are doing is a group of objects are stored in another object which is part of another object which is normally a set or a list of those objects, and through that single persistent object the element can be accessible from the persistent object. So we don't need to add persistent name to all of these objects, just add persistent name to the basket. We will see example. So you can see department we have already defined class department, that was given in the previous example. So I'll be defining a new class, define class department set. It is having a type set of department. So it is simply a class that consists of a set of departments. Department we have already defined, right? Again, it also consists of some operations. Add department, department means we can add a department object here in the department set. Into that basket we need to add some department. So this basket is actually department set. Now add department. If I am adding one department into that, if you add one department into that, add department of that department name, department, that must be given as the parameter of add department function, and which returns a boolean type value. So description is given here, adds a department to the department set object. So this is the class department set. When we create an object for that, it will become, this basket will become, so this is one department, for example CS department. Similarly we will be having another basket which is ECE department, for example. So there will be some department set, and into which some departments are being added. Okay, so just imagine inside CS, assume that we are having different sessions like AI, different sub departments are there. For example, inside ECE, if you are having different sub departments are there, we are doing this concept. So similarly, remove department, department boolean, the same format we are following here also. If you want to remove a department from that department set, we can use remove department operation. Then similarly we can create department set. Create department set is used to, it is just like a constructor in order to create a department set object. So department set is the class. If you want to create an object of department set, we can use a constructor create department set. We'll create an object of department set. Similarly, if you want to destroy that entire basket itself, we can use destroy department set, which is returning a boolean. Okay, so in this case, object-oriented databases, we should return something. That is why we cannot leave it simply. So that is why we are simply returning boolean value, or we should return any other built-in type value or some user-defined type value or object as a return type of any operations present in the object-oriented classes. Then end department set. So this is the first phase. What we are doing, we are having employee department available. Now we are creating a new class called as department set that consists of a set of departments. Its type is set of department. Then we are adding, in order to include some departments into that department set, we are adding some operations like add department, remove department. Then for this entire class department set, we are creating a department set object, and we are using a destroy. If you want to remove that entire basket itself from the database, we can use destroy department set. And end department set, that is the end of this particular class. Now we have created a department set class. Now what we are going to do is, later we will be providing a keyword here, persistent name, persistent space name. So this is an important question, how we can make an object reachable through a persistent object. How an object is being reachable through a persistent object. Directly it can be a persistent object. We can directly make an object persistent, or else we can access or reach a particular object through another persistent object. So we need to make some of the object as persistent. So providing persistent name for all the objects are not an easier task. So what we are doing is, a group of objects are together gathered into a set of department, and that object will be given a persistent name. So you can see persistent name all departments colon department set. So what we are doing is, we are providing a persistent name for department set, and the name given is all departments. We can provide our own names, user defined names, but before that we should use the keyword persistent space name. This statement indicates that all departments is a persistent named object of type department set. So now all departments is the name of an object of type department set class, which is given a unique persistent name. Now through this all departments, we can access, or the different objects, different department objects can be reachable, because all departments is a persistent object name, and all the departments are under that all departments persistent object names. Now through this all departments persistent object name, other objects can be reachable. So our heading was like reachability. Okay, now later d equal to create department, so I will be creating a department. D equal to create department, it will create a department. Then b is equal to all departments dot add department. All departments is the persistent object name dot add department of d. So whichever department that is created now will be added into the all departments. Now this d is reachable. Okay, d is reachable through all departments. So d is a separate department which is not persistent actually, but now d is persistent by adding it to the persistent set of the persistent set of all departments, which is already given a persistent name. Now d is reachable through all departments, which is a persistent object name. Now automatically what is happening is d is also becoming persistent. We are not providing any persistent name for department d object, but through all departments persistent object name, this d will also become persistent. So we don't need to, so it is always difficult to add persistent name to all the objects. So what we are doing is we will group some objects together and form a different class, and will be having an object for that class, and that single object is given a persistent name through which the objects present inside that persistent object can be easily reachable. I hope it is clear. This is a mechanism that is used to access all the objects easier in the case of an object-oriented database system. So this is a very important question, how we can provide a persistent name. So how persistence can be maintained in object-oriented databases, how the object can be reachable by using a persistent object. So all these are coming under the concept called as persistent name that is given to any object. So we are not using the same name of the class here. We will be using some other object name that will be the object of a group of the type or the class that we are defining. Now we will look into another property of object-oriented databases, that is called as type and class hierarchies and inheritance. Class hierarchy or type hierarchy or inheritance. It can be like inheritance in C++ and Java. Class hierarchy, it is like interface in Java. So there can be one class is defined from another class or extended from another class, or some class when it is inherited, only few properties are inherited, some other things are restricted. So we are having this type and class hierarchies by using the common property called as inheritance. So we will see what is type or class hierarchy. So type and class hierarchy, they are considered as same. So a type in its simplest form can be defined by giving a type name that we have already seen, and then listing the names of its visible functions. So for simplicity, we are going to give example where we are providing the name of a type or class, then we are providing the list of functions that are visible. For example, you can see type name colon a function separately up to a number of functions. This is not the format actually, this is only for discussion. We are using this syntax in order to discuss about type or class hierarchy. An example can be given like person is a class or type which consists of these functions. Functions name can be a single attribute, can be a single normal type. It can be a user defined type. All cannot be a function, but generally it is called as function. Some of them are function also. So a person consists of name, address, birth date, age and social security number. Means person is a class that consists of name attribute, address attribute, birth date, age and SSN. That's all. Exactly it is not like this, it is only for explanation. So person class is defined. Now we can call two types, a subtype and supertype. What is subtype and supertypes? As you know, superclass and subclass, it is similar to that. A class is there, superclass and subclass. Similarly, a type is there, supertype and subtype is there. So what is subtype? When a designer or user create a new type that is similar but not identical to an already defined type, that is called as a subtype. So I will be creating a new type of base type. It is not exactly same, but some properties are inherited here. This is called as subtype. Now what is supertype? It allows inheritance of all the functions to the subtype. So this can be called as the supertype. It allows inheritance. That means the creation of a new type is permitted by this type. So this is called as supertype. Exactly similar to superclass and subclass. I will see one example for this type and class hierarchies in inheritance. One of the example, like person is a class or type with name, address, birth date, age and SSN, which was already given before. Then employee is another class. So if you want to define employee, normally what we will do, we will write name for employee, we will be writing address, birth date, age, SSN. Then we are having salary, hire date and seniority. Then again assume that for the same operation we require a student type also. Again we are having name, address, birth date, age, SSN, major in and CGPA. Now you can see that among these three examples, in person, which is the first type that consists of name, address, birth date, age and SSN. Employee also consists of name, address, birth date, age and SSN. Student also consists of name, address, birth date, age and SSN. So we are repeating all the same attributes again and again. So in order to minimize those redundant data while creating new type, we are doing the inheritance by avoiding the repeated elements or properties to be avoided in the subtype. So we can replace this symbol. So person is the first type. Now how we can write employee? Employee space subtype of, which is a syntax used in the object-oriented database. Employee subtype of person. So employee is defined as subtype of person. Automatically all the person data will be available here. Colon. Then I'll only provide salary, hire date and seniority, which are new. So automatically what is the property of employee? Employee will be having name, address, birth date, age, SSN, then salary, hire date and seniority. It is just like base class and subclass in C++. Now similarly student is subtype of person, colon, major and GPA. So we can create a new type or class based on an already existing class. So some of the elements or the attributes need not to be repeated in our subtypes also. So which will make the creation of subtypes easier. Now we'll see one more example of this type and class hierarchy. Consider one more type where we are describing a geometry object which consists of the operations shape, area and reference point. Assume this is the base class or base type. Now we can create a new type, rectangle, subtype of geometry object, by adding, along with the shape, area and reference point, I'll be adding width and height, because for rectangle we require width and height specifically for doing some calculation. Now similarly for triangle, which is a subtype of geometry, the same geometry object, it requires side 1 and side 2 and angle. It requires 3 different dimensions along with the same shape, area and reference point. Similarly we are having a third subtype, that is circle, which is subtype of geometry object with radius. Again this is also an example for type and class hierarchy. Now we can see that we can have an alternative way of declaring these 3 subtypes. A different way also we can do the same thing, because we are having different shapes. Geometry object is having a common shape attribute, and the name of this subtype will be deciding the shape of those geometry objects. So we can have the same thing can be repeated by using another syntax. You can see here rectangle, subtype of geometry object. Within bracket I'll be providing shape is equal to rectangle, then provide the required new dimensions. So specifically for rectangle we are creating a new type which is called as rectangle with attributes width and height that is being added. Now again triangle, subtype of geometry object, for shape equal to triangle, side 1, side 2 and angle. This is exactly similar to the previous one, only a slight difference here. Similarly circle, subtype of geometry object, shape is equal to circle and the attribute that is being added is radius. I hope it is clear. This type and class hierarchy can also be asked as a short question. How this type and class hierarchy or inheritance can be implemented in the case of object-oriented databases. So sometimes you may need to give some example types and subtypes. Now along with this type and class hierarchy or inheritance concept, we are having some more terms. So just listen to these terms. Like first term is extents. That is the collection of objects means what is actually extent. we are calling types as well as class here. Now normally this collection of objects are actually part of extends, because if you want to extend something, means if we want to create some more new types, we'll be having some existing types available already. So what is an extend? So that for inheritance purpose we are using the concept of extends. So extends are actually the collections of objects of same type. So that is the main difference. So there are some objects available, so similar objects together, just like we were discussing about persistent object before. Similarly, in order to store the similar type of objects together, we are using an extend concept. So extends normally consist of various objects of same type. Maybe it can be a grouping of objects. Now another term, so remember the term extends. What is extends? Group of related or similar objects into a single, what to say, it is like another type. So the extend type will be having collection of objects of same type. Now persistent collection means collection of objects that is stored permanently. Persistent collection, we have seen persistent objects in the previous example, previous case. So persistent collection means the collection of objects which is permanently stored. So anytime we can access those collections. So all the objects are not permanent. Maybe we know in C++ and all, whatever objects we are creating, the object will be retained only up to the completion of that particular program. Then the object will be automatically, or we need to delete that. So object persistence is always important, because this is about the storage of object data to be stored permanently for any future uses. So persistent collection is the term that is used to store the collection of objects and that is to be stored permanently. Then transient collection is the collection of objects that will be that will not be existing, or that is a temporary existence only, and it will be removed from the system when the program terminates. That is called as transient collection. So transient object or persistent object, it's the same thing. Persistent object means object will be retaining there, but transient object means object will be terminate, or that will be removed whenever the program terminates. So different situations we require these two types of collections, persistent as well as transient collection objects. Now finally we will see some basics of complex objects. So complex, so in the later session of the same module we will be discussing about various complex objects. So complex objects means an object with more complexity, means more tuple elements further, that is being divided into a number of further types. So automatically the object will become complex. So there are two types of complex objects basically. One is unstructured complex object. It is provided by DBMS and permits the storage and retrieval of large objects. Normally unstructured complex objects are used to store large objects that are required for any database application. Huge amount of data storage. We cannot use a structured type, we are using an unstructured type. That is some examples like bitmap images consist of lot of objects. Then long text strings like documents, PDF document and all, they are usually called as binary large objects, or BLOB in short. So in order to have, so all these objects will be bitmap images, PDF document, or other objects, larger documents will be having, even larger videos also, it will be having a complex structure which is unstructured. Not only the structure is complex, it is unstructured. So this has been the standard way by which relational database have dealt with supporting complex objects, leaving the operations on those objects outside the RDBMS. So in normal traditional DBMS, they are using this unstructured complex object, and the object related operations are not normally possible with a relational RDBMS system. So that is done actually separately. Now what about the structured complex object? So what is the difference here? The difference is that the object structure is defined by repeated application of type constructors. So in the previous slides we were discussing about the creation of different types or classes by using the repeated usages of type constructors like tuple, set, etc. And if you are following that specific structure, it can be called as a structured complex object. So the object structure is defined and known to be that must be known to the object-oriented database management system, and it also defines the methods and operations that are required for the classes or types that we are defining using OODBMS system. So structured complex objects are very much structured by using different type constructors, but unstructured objects are not having any specific order and all, which will be having huge amount of data. Huge or larger objects are stored separately without having any specific formats. Now the next feature, another feature of or other concepts related to the object-oriented databases is polymorphism, one of the major one, which is also called as operator overloading or operation overloading. It allows the same operator name or symbol. So you are familiar with polymorphism. So the same thing is repeated here also with different implementations. So same the plus. So we can see a plus operator can be used for addition of integers, and also in a different situation it can be used for concatenation of two strings. So similarly in object-oriented database also we can have the concept of polymorphism that supports the same name, same operator name with different implementation or different meanings. Then similarly the object-oriented databases supports multiple inheritance and selective inheritance. So what is this multiple inheritance? Multiple inheritance means a new type is defined from more than one type. That is called as multiple inheritance. That is also supported by object-oriented databases. Here a subtype T is a subtype of two or more base types, which is also supported by object-oriented databases. So you can see we can create a subtype engineering manager, which is a subtype of both manager and engineer. So this is another object-oriented concept that is associated with object-oriented databases. So this session we were discussing about some other features of object-oriented databases, like the creation of a particular class, then other features like type and class hierarchy, then adding operations, then persistent objects, and other features like polymorphism and multiple inheritance, etc. So these are the basics about the part 1 of module 2 is about to finish now. That is the basic concepts of the usages of object-oriented databases, primary features, how the different types can be formed, and how it can be converted into classes, and the various elements present in a class like instance variables and operations, and specialities of operations, then the importance of persistent object, how to make an object persistent, how to reach an object through a persistent object, and the type and class hierarchy, that is inheritance property, then polymorphism, and different types of inheritance. So that's it for now. In the next video we will be looking into some more object-oriented database in real database system, how we can create a real classes and the various other features of object-oriented database system. So we'll be looking at some specific object query languages and all. We'll specifically take some object language, object-oriented database, and we will see the syntax. The same thing will be described in that object-oriented database syntax. So that's it for now. Thank you.